Hello, students. Welcome, my viewers. This is Science Classics. Science Classics. Remember, we are still under the topic energy, and topic energy, we are dwelling on light. And if you remember, our previous lesson was about reflection of light and its uses. So today's lesson, we are going to learn about refraction of light. Refraction of light. First, we will find out what's the meaning of refraction of light. What is refraction of light? When you talk of refraction of light, we are talking about bending of light. So, refraction of light is the bending of light as it moves from one transparent medium to another transparent medium. Bending of light as it moves from one transparent medium to another transparent medium. To another transparent medium. So, as rays of light passes one transparent medium to another transparent medium, there is change in speed of light, and this change is brought due to the medium, the common media which we have here. Let's talk of common media. We have common media. We have two main common media here. For example, I have water. Number two, we have air. Now let's take these two medium. Light, assuming now light is moving from the air to water, there will be bending of light, and this bending of light is brought due to density, change in density. Bending is brought due to change of density. Remember, when you see water and air, these two materials, they have different density. I'll say water is denser than air. So, because they have different density, there is what we call change. Change in speed of light. There is change of speed, the speed of light as it travels from water to air, or traveling from air to water. This speed change is brought by density of the material. Now, when you talk of refraction, where does it happen? This one takes place at the boundary The bending takes place at the boundary of the medium. Let's give example again. Now this is air and this is water. Let's say again this is air and this is water. I want to give two scenarios. One, let's say the ray of light is traveling this way. We want to see what will happen. Then, assuming there is another ray moving this way, we want to see how this one will happen. So, as the ray of light moving on air at a certain speed reaches the boundary between the air and water, because air is less dense than water, there will be change in speed, which means the speed at what the ray of light was moving in the air will go down when it reaches water. So this change takes place at the boundary. You must know, where does it take place? At the boundary. It takes place at the boundary. So if this is or if this is a ray of light, which means if there is no water here, it will continue moving at the same speed. It will continue moving at the same speed. So what happened when this ray hit the boundary between air and water? It slows down. You will see it bending this way. Let me make it a bit bold so that it can be seen. Let's say this is ray of light. You will see it bending this way. The same as this one. Let me make it bigger so that it be conspicuous. Let's say that's one ray of light. So it's moving this way. When it reaches this point, the speed reduces. Then that leads to bending at this point, because then water is denser. Air is less denser than water. So you'll see it appear that way. So that's what we call refraction of light. And this thing happen in our common daily life. Whereas also we can also add another medium here. Medium number 3 as glass. We know what glass also is a transparent medium. So when you add glass, you will have a different change, which means now you realize glass is now is denser than water. So density of glass is higher than that of water, and density of water is higher than that of air. So I'm going to give an example of this one and how it happens. Before I close this one, remember we were talking about refraction of light, whereas you have said refraction of light is bending of light as it moves from one transparent medium to another transparent medium. Common medium which we have, which are also transparent, we have said water, we have air, and we have glass. Then here I have given two things. Let's put a boundary here to show that that is one side, this is the other side. This is 1 and this is 2. And what do we have? We can see here bending. Bending is brought due to change of density because water is dense than air and air is less dense than water. Comparing glass and water, glass is dense than water and water is less dense than glass. And you see how bending takes place. So don't take it wrong because some learners mistake this thing and draw it wrong, whereas you find a learner drawing this way. If this is water, sorry, if this is air and this is water, you will realize some learners, they draw it this way, which is wrong. So you must be careful how it is supposed to move. When it is coming this way and you do a mistake of bending it this way, that one is wrong. It is supposed, this one is wrong. It is supposed to move this way and this way. You see the way it is coming closer. And for this one also, if this is air and this is water, this is what you're not supposed to do. If you do it this way and this way, that one is wrong. And it's supposed to be this way and this way. This one is right. This one is wrong. This one is wrong. This one is wrong. This is right. So this is right and this is right. You must know how it is supposed to be moving. Now I want us to go to other examples. As we go to other examples, you will be trying all these ones at home and at your own pace. So we move on. It's okay there. Now, I want to give some examples which you can do at home. For example, refraction of light can be observed in the following cases. These are cases where we can observe refraction. There are cases where as we can observe refraction, and I'm going to start with the common one. Common one, this one is where as a ruler in water, in a glass. For example, if I have a ruler like this one, this is called a ruler, and make sure you have a glass. Your glass must be transparent. And like this one, if you check this one, it is not transparent. So I was saying, make sure you avoid such containers. We don't need like this one. And when using a ruler, we use a ruler like this one here. You can see this kind of ruler which I have here. And now I want to give you an example of a glass, or you are supposed to use glass like this one here. So we want to investigate because this is ruler. We call it plastic ruler. This is a plastic ruler, and this is water. So you dip it. You make sure your glass is full of water. Then you dip your ruler inside. As you dip your ruler inside, you observe. Make sure you keenly observe at the surface of water, the surface of contact where water you check where water meets the ruler at the surface of water, you will see the ruler appears bending. Remember, the ruler is not bending. The ruler appears bending. The ruler is not bending. The ruler appears bending. What makes the ruler appears bending is the bending of rays of light. It is the light which bends, because this light, it is what enables you to see. We can't see without reflection. And reflection, as we learned in the previous lesson, we said reflection will only take place when there is light. And for you to see, there must be light. So the way this ruler is moving towards the container, the same as rays of light moving into the container. So when rays of light come into contact with water, and the water is denser, water has high density compared to glass, what happens? Rays of light bend. And because rays of light bends, and they are the ones which enables you to see, and for you to see, reflection must take place. So what happens? The ruler appears bending. It is the rays of the light which bends. And remember, you can't see them, but you can see the ruler. So the ruler is giving us an evidence that rays of light bend when they come into contact with something which is denser, especially when they're moving from less dense material. So a ruler dipped in a glass of water appears to bend. A ruler dipped. A ruler dipped. When you dip a ruler dipped in a glass of water. In a glass of water, how does it appear? When you dip ruler inside glass of water, how does it appears to bend due to refraction of light? Appears to bend due to refraction of light. It appears bent due to refraction of light, and that one we can show by drawing this way, and assume this is surface of water. So that's our ruler. That's our ruler. What will happen? Our ruler will appear at this point. You will see the ruler appear this way. It appears moving this way. What about if the container is this way? Now this is the container, this is the container. Then now this is at the surface of water. Now I decided to twist my ruler to be on this side. What happened? The ruler appears bending like this way, appears bending this way. And if you are asked at what point does it appear bending? At the surface, this is surface of water, where water and air meets at the boundary, boundary of water and air. That's where the bending takes place. There are other things. For example, if I take a coin, just using the same container, having the same container, and with my container, if I have a coin here, what happens with my container and this my coin, if I dip the coin inside the container, instead of this coin appearing at the bottom, it will seem to be somewhere here. That one is due to refraction of light. So what we say, when a coin is placed in water, it appears raised. A coin in water appears raised. A coin in water appears raised. I may also give a drawing using that one. For example, this container here, and now this one should be where the coin is. This one should be the real coin. And if this is the real coin, what happened if this water, where will the apparent coin appear? It will appear to be somewhere here. We call this one apparent coin. That's why we call refraction apparent bending. So this is water. So real coin, apparent coin. Then this is just a glass of water. Now these are examples of refraction of light. I want to give you other examples of refraction of light. Floors of swimming pool. Floors of swimming pool. When you talk of floors, let me talk number 3. Floors of swimming pool. Appear shallow. When you go swimming, you'll find floors of swimming pools, or when you check the containers carrying water, also appear raised or shallow. Why do they appear raised or shallow? They appear raised or shallow because of bending of light. We have other examples like riverbeds and floors of ponds. They will appear shallow. A pencil appears broken when dipped in water. Just like for this one, even a pen. If you put a pencil or pen, let me give the example of a pencil in water. Having a pencil like this one of mine here, if I dip this pencil here in water, what will happen? My pencil will appear broken. And at what point? At the surface where air meets water. So a pencil appears broken when dipped in water. A pencil appears broken when dipped in water. Other examples, we have formation of mirage. Mirage? Formation of mirage on the roads. For example, a mirage is a unrealistic pool of water formed on the roads in hot environment. For example, hot weather. For example, you are driving and ahead of you, you see a pool of water. And you see that pool of water, there are some rising or things rising up this they are shaking. That's what we call mirage. So that mirage or that pool of water you see, it is not real. That's just due to bending of light, which you call refraction. Objects in water appear larger than they actually are.